Alright, let's do some stoichiometry today for IGCSE chemistry. So a few pointers that we need to know is that the moles of a molecule or of a compound or of any element is equal to its mass, which is given to us, divided by its MR, which is the molecular mass. And the molecular mass is, the average atomic mass is AR. And let's say we have oxygen as the molecule. The molecule of oxygen is O2, and oxygen atom has an AR of 16, and so O2 will be 16 into 2, which is 32. So that's going to be the MR of the oxygen molecule, which is going to be 32. Now, concentration, this is only for liquids and gases. So concentration is equal to moles by volume, and that is basically C is equal to N by V. Now, the different volume conversions that we need to know of are that 1 meter cubed is equal to 1,000 decimeters cubed, and 1 decimeter cubed is equal to 1,000 centimeters cubed. One way to remember this is that 1 decimeter cubed is equal to one, not something I should know, but it's quite nice to know it. That will be that 1 liter is equal to 1 decimeter cubed, and 1 meter cubed is equal to 1,000 liters, and 1 centimeter cubed is equal to 1 milliliter. That's just extra information over that. Now, the ratios of the balanced equation represent the ratio of the moles in the reaction. So let's take a reaction. Let's take sodium hydroxide, which is aqueous, plus HCl, which will give us NaCl plus H2O. Let's see if this equation is balanced. There's one sodium atom, one chlorine atom, two hydrogen atoms, and one oxygen atom. So it is balanced. With this, we can obtain the ratios of the stoichiometric coefficients. So 1 mole of sodium hydroxide is needed to completely react with 1 mole of HCl to give us 1 mole of sodium chloride plus 1 mole of H2O. That's the stoichiometric ratio parts of the equation. And 1 mole of a gas at room temperature and pressure is equal to 24 decimeters cubed in volume. So if you have 0.5 moles, there will be 24 decimeters cubed into 0.5, which is going to be 12 decimeters cubed. That's it. So let's do some problems. Determine the volume of CO2 gas given off when excess MgCO3 is added to 25 decimeters cubed of 0.4 moles per decimeter cubed of HCl at room temperature and pressure. This one, the most important thing over here is that MgCO3 is in excess, which means that we don't need to do anything about this. We just consider the HCl. Now, this formula over here, which we need to use is, because HCl is liquid form, we're going to use N is equal to CV, or C is equal to N by V. So if C is equal to N by V, then N is equal to CV, right? Moles is equal to concentration into volume. The concentration we have been given is 0.4 moles per decimeter cubed, and the volume is 25 centimeters cubed. So to convert centimeters cubed into decimeters cubed, we have to divide by 1,000. So just put that in the calculator, 0.4 into 25 divided by 1,000, which is going to be 0.01. So this is going to be 0.01. 0.4 into 25 divided by 1,000. That's it. Now determine the number of moles of carbon dioxide gas given off. Over here, the moles of HCl is 2 and the moles of carbon dioxide is 1. So the ratio is 2 is to 1, and the moles of HCl we know is 0.01. So this is going to be x. You do some cross multiplication and you get x equal to 0.005, which is nothing but 0.01 divided by 2. So the moles of that is going to be 0.005, and the volume of it given in centimeters cubed. So first off, we're going to do 0.005, that's the moles, and you multiply that with 24 to get in decimeters cubed. Now you multiply that with 1,000 to get in centimeters cubed, which is going to be 120 centimeters cubed. Now, compound X contains carbon, hydrogen, and oxygen only. By mass, it contains 26.7% carbon and 2.2% hydrogen. So the rest of it is going to be oxygen, which is 71.1% oxygen. What is the empirical formula of X? The empirical formula means that it is the simplified formula for it, right? So let's take something like this is imaginary, it's not an actual compound. So let's say Fe2O4. This is the molecular formula. The empirical formula will be FeO2. So that's the difference over there. Yeah. Again, these are just imaginary compounds that are made up, they don't actually exist in nature. Um, so that's just an example over there. So over here, let's assume that the mass of X, of compound X, is 100 grams, which means that the percentage is the same as the grams, that's the mass in grams. So if it's 100 grams of X, that means that there is 26.7 grams of carbon, 2.2 grams of hydrogen, and 71.1 grams of oxygen. Now we have to find the moles of each of these elements. So 71.1 grams of oxygen means that the moles is 71.1 divided by 16, which is going to be, put that in your calculator, 71.1 divided by 16 is 4.4. Carbon is 26.7, so 26.7 divided by 12 is 2.2, and hydrogen is 2.2 divided by 1, so that is 2.2. Now the next thing is to take the lowest of these three, which is 2.2, and divide all of them, all these three, by 2.2. So this divided by 2.2 is 2, divided by 2.2 is 1, divided by 2.2 is 1. So therefore, the moles on the empirical formula of X will be, this is for hydrogen, this is for carbon, this is for oxygen. So oxygen has to be twice, which is only in this one, and carbon and hydrogen is one, so it's going to be CHO2 as the empirical formula. To find the molecular formula, you will be given the mass of the molecular formula's molecule, and you simply have to find the MR of this. You have the MR of that given, divide them, and you will get a factor which you have to multiply this with, the subscript with. I have an example of that as well. Now, calcium carbonate reacts with dilute hydrofluoric acid to produce carbon dioxide, and it says that there's an excess of HCl, which means that we don't consider this at all, we only consider this. Now there's 10 grams of calcium carbonate, and the MR of calcium carbonate is 100. So the moles of calcium carbonate is 10 divided by 100, right? Next thing is to find the mass of carbon dioxide produced. So we need to find the moles of carbon dioxide. The moles of carbon dioxide are in the same ratio, so 1:1 means that there are moles of CO2 equal to 0.1. Now we need to find the MR of carbon dioxide. So moles is 0.1, and that is equal to the mass by the MR. And MR we know is carbon is 12, oxygen is 16. So 12 plus 16 into 2, which is 44. So the mass is equal to 0.1 into 44, which is 4.4 grams. Now, another thing is that when you're using the formula that moles is equal to mass by MR, the mass has to be in grams. Yeah. Now, methane and steam react in the presence of a catalyst, and 0.5 moles of methane react completely with 0.5 moles of steam, which means that the ratio is, this is 0.5, this is also 0.5, this is going to be 0.5, and this is going to be 1.5. Yeah, so this is a 0 with that, this is 0.5, yeah. Basically, that's the stoichiometric ratio, because we know that 0.5 of that completes the reaction with 0.5 moles of steam. Now, if the room temperature and pressure is going to be 0.5 moles, is going to be multiplied with 24 to give us 12 decimeters cubed, and 1.5 into 24 is going to be 36. So the answer is going to be D, because carbon dioxide is 0.5 moles, which is going to be into 12 decimeters cubed to give us into 24 decimeters cubed to give us 12, and the volume of moles of hydrogen is 1.5 because of the stoichiometric ratio. You multiply the 0.5 over here with 3, and you get 36 when you multiply it with 24. Okay. Now, if 100 centimeters cubed of aqueous lead to nitrate of concentration 0.1 moles per decimeter cubed is reacted with an excess of sodium chloride, what mass of lead to chloride is obtained? So it says that there's an excess of sodium chloride, so we can completely ignore this sodium chloride over here. The only thing I focused on is this and this. So let's do this. Lead has moles of what? Moles is going to be mass, is going to be concentration into volume. So the concentration is 0.1 moles per decimeter cubed. So you multiply it with the volume in decimeters cubed. So 100 divided by 1000, which is going to be 0.1 into 0.1, which is 0.01. So you have 0.01 moles of lead nitrate and lead chloride. So I'm going to write PbCl2. Now to find the mass of it obtained, we just have to multiply it with the MR. So let's open the periodic table. Lead is Pb and Pb is over here. So it's 82 is going to be 207.2. That's the MR, because if you open over here, sorry, the average atomic mass that you're looking for is over here. So that's going to be lead over here, 207.2. So 207.2 plus fluorine is 35.5 into 2, which is 71. Yeah, chlorine is right over here, 35.5. So 35.5 into 2 is, like I said, 71 plus 207.2. So that's going to give us 278.2 as the total MR of lead chloride, of lead 2 chloride. And now we simply multiply it with the number of moles, which is 0.01, which is 2.782. Okay, now next, the question is 20 centimeters cubed of H2SO4 reacts with 25 centimeters cubed of 0.2 moles per decimeter cubed of NaOH, and we need to find out the moles of NaOH. So that's going to be again 0.2 into 25 divided by 1000, which is going to be 5 times 10 to the power minus 3. That also works. Now the moles of that has to react with NaOH. So the ratio is 2:1. So if this is the moles of NaOH, you have to divide that by 2 to get the moles of H2SO4. So I'm going to divide that by 2 and I get 2.5 times 10 to the power minus 3. So calculate the concentration of that. So we know the moles. We need to find, we know the volume, so we need to find the concentration. So moles we are given, divide that by the volume, is decimeters cubed. So again, 20 divided by 1000. And this is going to give us 0.125 moles per decimeter cubed. Now, next. It's a similar question again, but there's a conversion over here. So 20 centimeters cubed of 0.05 moles per decimeter cubed of HCl reacts with 25 centimeters cubed of CaOH twice, or calcium hydroxide. So the moles of HCl that are being used is going to be 0.05 moles per decimeter cubed into 20 divided by 1000 decimeters cubed, which is going to be 1 times 10 to the power minus 3 moles. Now the moles of CaOH twice in 25 centimeters cubed of that, it's going to have to be, the ratio is 2:1. So you have to divide the HCl moles by 2 to get the moles of CaOH twice. So that's going to be 5 times 10 to the power minus 4. So what's the concentration in moles per decimeter cubed? So the concentration in moles per decimeter cubed is going to be the moles that we got divided by the volume, which is 25 centimeters cubed. No, it's 25 centimeters cubed. So divide that by 25, because it's in decimeters cubed, we have to divide 25 by 1000 to get in decimeters cubed, and so the concentration is going to be 0.02. Now, to convert it into grams per decimeter cubed, you see that the decimeters cubed is still the same. The only difference is between moles and grams. So what's the formula connecting moles and mass? Well, moles is equal to mass divided by mr. So we need to make mass the subject of the formula, which will be mass is equal to moles into mr. So all I'm going to do is multiply this concentration, which is 0.02 moles per decimeter cubed, with the mr to get the concentration in terms of mass. So 0.02 into oxygen and hydrogen is going to be 16 plus 1, 17 into 2 is 34, plus calcium, which if I'm not wrong is 40. So I just drag across over here. Calcium is on top over here, which is 40. Yeah. So into 40, I mean plus 40. So the answer is going to be 1.48 grams per decimeter cubed. Now next, calculate the empirical formula, and then you have to calculate the molecular formula, which is where I said I have a question. Yeah. So this may make sure that this adds up to 100 first, and I'm confident that it will always add up to 100 because at the IGCSE level it will always add up to 100. So this is approximately this is 99.99. Just take that to be 100. So the empirical formula was going to be, it's going to be 31.37 divided by 16 to give us 31.37 divided by 16 is going to be 1.96. So 1.96 moles of oxygen. Then you have carbon, which is going to be 58.82 divided by 12, which is going to be 4.9 more of carbon. And then we got hydrogen, which is going to be 9.8. So you divide everything by 1.96 because that's the smallest value, and that will give us 1.96 divided by 1.96. So the oxygen is going to be once, carbon is going to be how many times? 4.9 divided by 1.96 is 2.5. So C 2.5, H is going to be 9.8 divided by 1.96 is going to be 5, H5O. And what I'm going to do is now multiply these subscripts with 2 to get C as a whole number. So this is going to be C10, C5, sorry, and then H10. So I'm just going to cross that out. C5, H10O2. So now it says that the relative molecular mass of the empirical formula is this. This is a different question, yeah? So S to Z has an empirical formula this, and the relative molecular mass is 116. Calculate the molecular formula of that. So what we have to do is find the MR of C3H6O. Carbon is 12 into 3, plus H6 is going to be 6, plus oxygen is 16. So that's going to give us 58. Now we need to find out the ratio between the relative molecular mass of the molecular formula and the relative molecular mass of the empirical formula. So that's going to be 116 divided by 58, which is 2. And therefore, we need to multiply the subscripts of the empirical formula with 2. So it's going to be C3 into 2 is going to be C6, H6 into 2 is H12, and O1 into 2 is O2. So that is the molecular formula of the ester Z. And yeah, that'll be it for stoichiometry. Any doubts, you can let me know in the comments and I will answer them.